Hello students, today I discuss our elasticity. So the definition of elasticity and some examples about the topic related with elasticity. So what is elasticity? First I describe. So the definition is that a body when acted upon by a system of balanced external forces does not move, but different portions of the body gets relatively displaced, then the original size or shape of the body changes, but the body is said to be deformed. Means that shape and size of the body will not be changed original, but under the balanced external forces, but actually under the balanced external forces the body gets relatively displaced, but its original size and shape of the body will not be changed. Then the body is said to be deformed. So its original size and shape must be kept unchanged, but different portions of the body gets relatively displaced. If we take any body, its different portion can be displaced, but its original size and shape must be unchanged. Then the body is said deformed. So what is relation with deformation of a body with elasticity? So when a body is thus deformed, then an internal force come into play and resist such deformation. So when a body is deformed, an internal force raised in the body which plays and tries to stop the deformation. So this internal force tries to stop the deformation of the body. This force tries to bring back the body to its original shape, and this internal force which arises against the deformation tries the body to bring back to its original shape or size. And on the removal of the deformation of the force, so when a force will be applied on a body, just changing the size and shape, then the body become deformed, and against the deformation the body generate an internal force which tries to return back the body to its original size and shape after the removal of the deformed force. So this property of the body is said elasticity. So this property of any body is said the elasticity. So an internal force generation in a body against the deformation of the body of any body, such kind of property is called elasticity of the body. So this is the definition of elasticity. All bodies are found to behave as perfectly elastic within a certain limit. So just a certain limit, all bodies behave perfectly elastic. Means that elasticity will work perfectly under a certain limit. After the limit, the body could not behave like a perfectly elastic. The deformation force, deforming force, which is called elastic limit. So this limit under which the body tries to perform perfectly elastic is called elastic limit. Now the ratio of change in the length, volume of shape of a body to its original configuration is called strain. So the ratio in change either in length or in volume or shape of a body to its original configuration is called strain. So what is strain? The ratio of change in the length, volume or shape of a body to its original shape. So if we take the ratio of the change and the original shape, the ratio is called strain of the body. It is a pure number and has no unit. So the strain, because it is a ratio of to length or to volume, so it cannot be it is a pure number. It cannot have any unit. Now when the external deforming force uh, causes strain in a body, an internal force in the body resisting its deformation. As I have described, an internal force works against deformation, which is the elasticity. So uh, the internal force acting per unit area is called the stress. So this is the internal force or the elasticity of the body acting per unit area is called the stress of the body. So this is the definition of stress. Now the unit of stress is Newton per meter square, because the internal force acting per unit area. So areas unit we know in SI meter square, and forces unit Newton. So Newton per meter square is the SI unit, and dyne per centimeter is the CGS units of the stress. So these are the units of stress, but strain does not have any unit. Now I describe what is Hooke's law. So within the elastic limit means the perfectly elastic. I have said the body when under a limit the body performs a perfectly elastic. So under this limit, within the elastic limit, uh, stress is proportional to strain. This is the Hooke's law, that within the elastic limit we always get stress is directly proportional to strain. So this is true only for small strain, means where the body performs perfectly elastic, and in the case of solid body also. So we will get the mathematical representation that stress by strain is equal to constant. Now this is a Hooke's law. So there are some modulus related with Hooke's law. For solids, we have Young's modulus for a case of solids. So what is Young modulus? When a body is deformed along the length by a deforming force, and the strain produced is called longitudinal strain. So if we consider for solids and the length of any wire, then if through a force if we try to stress the length, then the strain caused will be called longitudinal strain, and the stress produced for this for the force or under the force is called longitudinal strain. So Young modulus is the ratio of the longitudinal stress and longitudinal strain. So how mathematically it can be represented? If we take length of the wire is L, capital L, and the cross sectional area is A, the increased length we are taking under a force, the stress under a stressing force, the increased length is delta L. So delta L means many very small increased length. Then the longitudinal stress will be force per unit area, means force by cross sectional area A, and longitudinal strain will be this is I have written wrong. this will be delta L by L, means the increased length or stage length by original length. So here also it will be changed. This is delta L and this is L. So here this will be L and this will be delta L. So Young modulus is the longitudinal stress by longitudinal strain. Its formulation in this way, FL by A into delta L. So this is the Young modulus for solids. Now we will discuss about Bach modulus, which is for liquids or gases. So what is Bach modulus? Where there is only the change in volume of the body under the external deforming force, the strain produced is called volume strain. So here the strain called volume strain in the change of the volume, and the stress produced is called volume pressure. Actually here actually we know that what is pressure. The normal force per unit area is called pressure. So here force by area will be equal to this is the definition of pressure, that normal force acting per unit area is called pressure. So here the stress will be the pressure for Bach modulus. So pressure is the strain. So this is called volume stress or pressure. So Bach modulus will be volume stress by volume strain. Volume stress is equal to pressure and volume strain is the change in volume. So here the diagram, there is a piston on a cylinder. There is a V volume of gas and a piston pressuring P. And now if I withdraw some pressure delta P minus delta P is now acting, then there will be by Boyle's law that there will be increased in volume. So the increased volume is delta V. So the pressure of a gas is P, initial pressure, and the volume is V. Now later the decreased pressure is delta P, which is decreased, and the increased volume is delta V. Now volume stress is the change in the pressure, because volume stress is equal to pressure, so change in pressure is minus delta P. Minus will show that because it is negative, decreasing, and volume strain is delta V by V, means delta V is the change of the volume and V is the original volume. So delta V by V. So Bach modulus is represented by K. Young modulus is represented by Y, capital Y. So K or kappa you can say equal to delta minus delta P by del V by V. It will be minus V into delta P by delta V. So this is Bach modulus. Now modulus of rigidity. Modulus of rigidity is that when there is only a change in the shape without any change in the volume due to external deforming forces. If we take such kind of a three-dimensional figure, its ground area is A and upper surface area is A. Like a book, if you can take, if we take apply a force F tangentially on the upper forces, then it will the upper surface will be replaced in a new place by creating with the ground surface angle theta. So here theta is the actually theta is its shearing strain. This theta is called, we call shearing strain, and shearing stress is force by area, means F, and the surface area is we are taking A. So modulus rigidity is equal to, it is dependent by eta, shearing stress by shearing strain. So F by A by theta or F by A theta. So I discuss other related topics of elasticity in another video. If you like, then share with your friends.